Hello. Hello, Harsh.
Hello, sir.
How are you?
Fine, sir. What about you?
I'm also fine. So, in the last class, we have discussed this series and parallel combination, and today we will solve some questions. The first question is, three capacitors,
Yes,
1
sir.
microfarad, 2 microfarad, and 3 microfarad are joined in series. So here, capacitor. This is the series connection.
Yes, sir.
They are connected in series with some battery. They are 1 microfarad, 2 microfarad, 3 microfarad. And they are asking how many times will the capacity will become when they are joined in parallel. When they are joined in
Parallel.
first, we will calculate the resultant capacitance in series, and after that, we will join these capacitors in parallel.
Yes.
So for the series combination, the value of C equivalent
is equal to C1 plus C2 plus C3.
1 upon
1 by C1 plus 1 by C2.
this
series.
1 upon C2 plus 1 upon
C3. So it will be 1 by 1 plus 1 by 2
Yeah.
plus 1 by 3.
This will become 1 divided by 1, 1 divided by 2 plus 1 divided by 3. Now take the LCM 6. This will become
6 and then
3.
3 and then 2. So it will be 5 by 6, right? Oh, sorry. Yeah, sorry. 11 by 6. Yeah, 1 is also there.
6 plus 3, 9. 9 plus 2, 11 by 6. And when you will find C equivalent means CE. CE will come out to be 6Y. So the equivalent capacitance you have 6Y, 11 in parallel. No, sorry, in series. So you have equivalent capacitance in series 6Y 11 micro. Now we will connect this combination in parallel. So in parallel, we know how to connect. This is the parallel combination.
So,
and here is the battery.
Now the connection will be C1 plus C2 plus C3.
Yeah.
So it will be 6 by 6.
You can add. This is 1 microfarad.
Yes, sir.
This
2
is
microfarad, 3 microfarad.
This is 3 microfarad.
Yeah, so C equivalent is equal to
C equivalent when you will find in parallel, it will become
C1 plus C2 plus C3. So it will be 1 plus 2 plus 3. It is 6 microfarad.
6 microfarad. Now they are saying we have to find how much time the resultant capacitance will increase. So we will divide CE P divided by CE in series. So this was in parallel. In series we have.
So it will increase by 11 times.
Yeah, of course. You are right. So this will become 6 by 11, and in the denominator, here we will have 6, and 6
Yes, sir.
and 6 okay,
Will get
we can
cancelled.
write, yeah, it will become 6 by 11 into 1 by
6.
6. So this 6 and this 6 is cancel out.
Yes, sir. So it will be 11 by 1.
CEP is equal to 11 times of CE of series. Means the capacity when we connect the capacitor in parallel will become the 11 times.
Yes, sir.
So the capacitance will become 11 times. Next question.
Sir, suggestion, sir.
Do you want to note it down?
Actually, sir, someone's at the door. I have to open.
Okay, no problem.
Yes, sir, you can continue, sir.
This is the question. This is the question of CBSE 2006. Two capacitors of capacitance
6 microfarad and
12
connected in
microfarad.
series with a battery with voltage of 6
Microfarad
microfarad and capacitor 2 volts.
into the
So, the
total
total
battery.
battery voltage. Okay, so we'll find out the capacitance and multiply it with the battery voltage.
Now you can see the process how I will solve this. So they are saying, firstly, in solving the numerical, you should read the question carefully.
Yes,
That
sir.
they are saying two capacitors of capacitance 6 microfarad and 12 microfarad are connected in series. So connect first the capacitors in series. This is 6 microfarad, 12 microfarad connected in series with a battery, with some battery connected. And we don't know what is the potential difference of the battery. So I am supposing V is the potential difference or voltage. Let. After that, they are saying the voltage across the 6 microfarad capacitor is 2 volt. Means this is C1, this is C2. Here V1 is equal to 2 volt. Means the potential difference or the voltage across the 6 microfarad capacitor is 2
Is 2
volt.
volts.
And we have to find the total battery voltage. Means we have to find the value of V. We have to find the value of V. So first step is to calculate the equivalent resistance. First
Yes, sir.
step. So I have told you for the two capacitor, equivalent can be find like this C1
C1
C2,
plus C2, yes.
or you can also find with this 1 upon CE.
1 by C1 plus 1 by C2.
This is just the second step of this. I am just writing directly. So CE is, this is 6 into 12
into 12 by 6 plus 12.
This is 6 into 12 and this is 18.
So
And
it will be
6 3 is
sir,
this will become okay. 6 3s are 18 and 3
3
4s
4s
are,
are 12.
so we will get the 4
4
microfarad.
microfarad.
So the resultant capacitance is 4 microfarad, and
Yes, sir.
we know that from here the charge Q will flow,
Yes, sir.
and this is the series combination. So charge across C1 or charge across C2 will same.
Yes.
So you can say here Q1
C is
is
equal to
equal,
Q into V, right?
yeah, Q1 is equal to Q2 is equal to Q,
Q.
because
Yes,
this is
sir.
series combination, charge will
Yes,
remain
sir.
same. And if I want to find the total charge Q is equal to, then I have a formula C equivalent
Yeah.
equivalent into V.
Yes, sir.
Or first you should write this instead of this.
C is equal to Q.
Yeah, okay, you should write this. I will like to write this. If you want to find Q1 means charge across C1.
Yes, sir.
What is the Q1? Q1 is Q,
Charge,
same
yes,
charge
sir. Q.
Q. And for this Q is the total charge, and you can write this C equivalent means CE.
Yes, sir.
C equivalent is CE into V. CE into
V.
V1. Here we will take V1 because I am calculating Q1. So here Q into V1 is equal to
Yes.
charge
Yes, sir.
is equal to, sorry, Q is equal to C capacitance into V1 is equal to this Q.
Yes, sir.
So
that will be 4 into 2.
okay. So Q, from here you can find the value of Q. Q will
Yes.
become CE.
Where is 4?
Give me 1 minute.
Yes, sir.
Actually, this will not be CE. Remove all the things. I am telling again. Now see only the capacitor C1.
Yes, sir.
I want to find charge in capacitor 1. Charge in capacitor 1 is equal to Q1 is equal to C1 into V1,
Yes, sir.
and Q1 is equal to total charge
Yes,
Q,
sir, is equal to Q. Because it's in
and
series.
C1 is 6 microfarad
Into. Yes, sir.
and V1 is given to us. V1
It
is
is 2,
2
sir.
volt.
2
Yeah.
volts.
So charge Q will become 12
12 into 10 raised to minus 6.
coulomb.
Yes, sir.
So we have Q1 is equal to Q2
Q
is
is
equal
equal
to
to Q is equal to 12 into 10 raised to minus 6 coulomb.
So we have Q now, total charge. We have total
Yes,
charge.
yes,
We
sir.
have Q is total charge, and charge is equal to total charge is equal to total capacitance C
Yes, sir.
equivalent into total voltage V,
Voltage
and total charge is given as 12 into
into 10 raised to minus 6
we have
is
C
equal to
equivalent
4 into it's 4
4 into
V.
10 to the power minus 6 into V, and now we will
So,
find the
so
value of V.
the answer is 3.
Yeah, answer is 3.
Yes, sir.
So V is equal to 3 volt.
3 volts. Yes, sir.
So this is the required answer.
Yes, sir. Second, I write it.
Right. So
So from the second one,
see
yes, sir.
the question. So this type of question you will get in your examination. So
Yes,
see
sir.
the simplicity of the question. If you will please note it down.
Sorry, from the first, from the second answer. Sorry.
From the second you want to write this.
Yeah, for second. Yes, sir.
You have completed this now.
Yes, sir.
Okay, fine. You can write. This is not very. This is a good question. This is just a good question. I will.
So again, scroll down. So again, scroll down. Done, sir.
Now next question is this. This is a question of CBSE 2010. So first read the question carefully. Find the ratio of potential difference that must be applied across the parallel and the series combination of two capacitors C1 and C2 with their capacities in the ratio 1:3, so that energy stored in the two cases becomes DC. Now see. They are saying that once you are connecting these capacitors in parallel with some voltage V1, you have to see the language of the question. Find the ratio of potential difference that must be applied across the parallel and series combination of C1 and C2. This is C1.
Yes, sir.
This is C2, and the potential difference is V1.
V1.
And they are saying ratio of C1 divided by C2 is equal to 1 divided by 3. So from here I can write C2 is 3 times of C1 and first and the foremost step of solving the circuit is to find the equivalent. So find C equivalent for the parallel. For the parallel we have C1 plus C2 and put the value of C1 is same, put C1 is same and put the value of C2. So what is C2? C2 is 3 times
C2
of
is your
C1.
3 C1.
Yeah, C2 is 3 times of C1. So this will become 4C1. So for the parallel combination, equivalent capacitance will be 4 times of C1, and we have formula also for the energy.
Yes,
What is the formula for the energy stored in the capacitor? Q square by
Q is
2C,
Q.
2C,
Yes, sir.
half CV square,
Energy to
half
electrostatic to
half
half
QV.
QV.
But here, see here, we have only C and V, so we will use this
Yes, sir.
formula. We do not have charge. So for finding the energy of parallel combination, we will use half C equivalent. What is this? Is C equivalent. C equivalent of parallel into V1 square. Half, what is the C equivalent is 4 times of C1. V1 square is unknown. So this is our equation 1. So in the parallel combination, this amount of energy will be stored. Now connect these capacitors in the series combination. C1 and C2 in the series combination with some potential difference V1, V2, sorry. And this is C1 and this is C2. This is series. What is the value of C equivalent here in series?
So it will be 1 by C.
That can also be true,
C1
but
C1 plus C1 plus C2. Yes, sir.
C1 plus C2. C equivalent is this.
Yes, sir.
And you know that C2 is equal to 3 times of C1.
Yes, sir.
So put here.
C1 into 3 C1. C1 plus 3 C1.
This will become 3 C1 square. This will become 4 C1.
Yes, sir.
So I can write this 3 C1 into
C1
C1.
into C1.
This is 4 C1 and
Yes,
C1 C1
so
gone.
it's 3 C1 by 4.
Yeah, 3 C1 by equivalent capacitance is this, and
yes,
energy, if I want to find the energy in series combination, it will be half into C equivalent in series and voltage square.
Yes, sir.
C equivalent is 3 C1 by 4 and voltage in this combination is V2. This is equation 2. Now read the question again.
Yes, sir.
They are saying so that the energy stored in the two becomes the
The
same.
same. So half CB square should be.
Yeah. Means we have to equate UP, U suffix P equal to U suffix X.
Yes, sir.
Equating equation 1 and 2. Means U suffix P is equal to U suffix X. U suffix P is half 4C1 into V square.
Yeah, 4.
UP 4C1 into
4
V1
C1
square.
into V1 square.
4C1 into
V1 square.
And this is half into US 3C1 by 4
V into V2.
into V2 square. Now see here, this is cancel out. This is
Half
cancel out.
cancel.
From here, C1 is cancel out and C1
C1 is cancelled.
So on the left hand side, we have 4
V1 square.
And here we have 3 by 4 V2 square.
3 by 4 V2 square. So 4 will cancel.
No. This time not
No,
4.
yeah. This
You will
time
cross
it's,
multiply this 4 in this side.
yes.
So this will become 16
V1
square
square is equal to 3 2 square.
P2 square. And we have to find the ratio of voltage. Find the ratio of potential difference applied across the parallel. In parallel, we have V1 by V2. We have to find the ratio of V1 by V2. Means they are saying find the ratio of voltage in parallel. So voltage in parallel is V1.
Yes, sir.
And this will come this side. So this will become V1 by V2 whole square. And this will become 3 by 16. And when we will take the under root, square root, under root. So this will become root 3 and root of 16 will become 4. So this is your required
Yes, sir.
answer.
Yes, sir.
Please note it down.
Yes, sir. So we're going to scroll down.
Harsh, do you know we have one WhatsApp group?
Yes, sir. It's in my father's mobile, sir. Of physics.
Okay. And after this, after today, this chapter will be completed. After this, there is one more topic, and that will be completed, I think, in 45 or 30 minutes. So I am thinking that and someone also told me to take a test, not very complicated test. In the test, you will have only basic questions.
Yes, sir. You can take the test.
Yeah. In the next class, please try to revise your notes of this chapter only. Potential and capacity only. I will give the question from the capacitor only, not the potential.
Sir, for this chapter or the last chapter also?
Uh, for this chapter, you have to complete, not the
Okay,
last
sir.
chapter.
Okay, sir. No problem, sir.
And the question will be like this. You can solve if you have uh, given the observation in the class, then you can solve the question easily. I
Yes, sir.
never give the questions very hard, because in the examination also the questions are coming very easy. Why should I give you a hard question? What is the use of that?
Yes, sir.
Yeah.
Second column.
Yeah.
So, sir, next class, right?
Yeah, in the next class, please try to revise your notes of chapter capacitance
Yes.
from where uh, from the capacitance
Yes, sir.
from
So from
from the
electric potential and capacitance, only capacitance is coming.
only capacity,
Okay, sir.
not
No problem.
not that.
Okay, sir.
And in the assignment also, I never give the questions that takes more than 10 minutes.
Yes, sir.
Within 10, my question of assignments you can solve within 10 minutes. Within 10 minutes.
Okay.
Yeah. So I am saying to you that you should check the portal and
Sir,
see
I
there.
checked, sir. Again, there is that problem. It's not coming. I literally checked like half an hour before the class. It's not coming.
And they are saying the assignment is there, and they have
Sir,
sent this.
I can show you, sir. It's not there.
And the someone has sent me the screenshot. They are saying that the assignment is available on the portal. I don't know. Okay, no problem, but we can solve this problem. But in the
Second scroll
next
down.
class,
Yes, sir.
yeah,
Next
in
class,
the
you can
next
take the
class,
test, sir.
test will be of at least 15 minutes or 20 minutes.
Yes, sir. Sir, the fourth chapter, moving charge and magnetism, is kind of hard.
Current electricity.
No, moving charges and magnetism, the fourth chapter of
Oh,
electro.
that magnetism and all that.
Yeah, I was studying it today, so.
Not harder, very easy chapter. Actually, all the chapters are easy until you have until and unless you want to try to understand.
No, because in textbook it's not given clear, like nu is permeability of free spaces 4.10⁻⁷ and all that.
Yeah, you have to find the analogy. 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 Analogy means similarity. You have to find the similarity. What is the similarity in the chapter electrostatics and current electricity, electrostatics and electromagnetism, and after that alternating. So if you will
Sir,
do
it is
this
at
way,
that right hand thumb rule.
if you will do that way, and most importantly, you have to practice.
Yes, sir.
Everything is not everything is easy, not that complicated that you are thinking that chapter is complicated, that chapter.
Yeah, like it's
If you
not complicated level of 11th, but it is kind of complicated.
Yeah, when you will study something by heart, HEART, heart,
Yes, sir.
and with mind, then but your heart should be at the right position. Otherwise,
Done,
there
sir.
will be problem. Okay, now
Done.
fine.
Yes, sir. Yeah.
So now we have very small topic. This is the last of topic, farewell of There are two parallel plates. There are two parallel plates. One plate is positively charged. Another plate is negatively charged. And this is known as capacitor.
Yes, sir. Charges are on the surface of capacitor.
Yeah. And the distance between two plates is small d. And A is the area of each plate. Area of this plate is A. Area of this plate is. Now, what I am doing, I am filling dielectric. I am filling dielectric. What is this? This is dielectric in this
Yes, sir.
space. And we have another dielectric of yellow color, right? The dielectric. And this is dielectric. So here in this area, this is half of the area. This means in the area A by 2, a dielectric of constant K1 is filled. In the
Yes, sir.
in the another half area, a dielectric of constant K2 is filled. Dielectrics filled. This is the dielectric. Dielectrics are filled in half areas, in area. That is in A by 2 dielectric of constant K1 is filled. And in another A by 2 dielectric of constant K2 is filled. So here we have filled a dielectric of constant K1 and here we have filled a dielectric of constant K2. So right here K1, here is K2. And one thing I have told you, in case of capacitor, tell me whether this is a series connection or parallel connection.
Parallel, sir.
So if this is a positive terminal, so in this way this is again a positive terminal.
Positive, and then negative.
Negative, this is negative.
Yes, sir.
So in the parallel combination, positive plate is connected with positive plate,
Yes,
negative
sir.
plate is connected with negative plate. So see here, from this point, from this line, here is some another capacitor now. This becomes another capacitor of capacitance C1. This becomes capacitor
C2.
of capacitance C2, and they are connected. Positive plate is connected with positive plate, negative plate is connected with negative plate. So this is the parallel combination.
Yes, sir.
And if I want to find C1, if I want to find C1, what is the, if I want to find C1, so only you have to remember the formula. Epsilon naught into area of plate. What is the area? And divided by the distance between plates. Distance between plates.
Plates.
The formula is
C epsilon naught A by D.
capacitance C is equal to epsilon naught
Epsilon naught A by
into area. I am writing in
by
terms of
distance.
area y. Distance between plates.
Distance. Yes, sir.
Between plates. Now, when you are calculating C1, epsilon naught is there. And one thing more. Here you will take K epsilon naught because there is K also, because we have filled the dielectric also. I have told you na, when you filled capacitor with dielectric K, then capacitor will become K epsilon naught into area divided by distance.
Yes, sir.
So here this will become K epsilon naught area divided by distance between the plate. So C1 is K1, and if you want to find C1, then you will take K1 and then you will take epsilon naught. Then what is the area of for C1? Area for C1 is
A by 2.
yeah, A by 2. And what is the distance for C1? This is C1. Distance is D. Distance
D.
is not changing.
Yes, sir.
So for C1 you can write K1 epsilon naught A divided by 2D. This is C1. And when you will calculate C2, you will get K2 epsilon naught A divided by 2D. And we know that if we want to find the equivalent capacitance for the parallel combination, what is the formula? C1 plus C2.
Yes, sir.
So what is C1? K1 epsilon naught A divided by 2D. Plus K2 epsilon naught A divided by 2D. And 2D is the LCM. So this will become from here we can take common K1, we can take common epsilon naught A divided by 2D is common, and here is K1 plus K2. This is C equivalent of parallel combination when the capacitors are filled with different dielectrics. When a single capacitor is filled with dielectric. So here you can say, if area divides, then the combination is positive. Oh, sorry, not positive. Combination is parallel. If area divides, it means that parallel combination. Area divides means we are filling the dielectrics along area. In half area, we are filling dielectric, another dielectric, And if in half area we are filling another dielectric, so we have this formula. And there is one another case. This is one plate of capacitor. This is another plate of capacitor. This is a parallel plate capacitor, and this is positively charged plate. This is negatively charged plate. And the distance between the plates is D. Now this time what I am doing, I am filling dielectric between the plates of capacitor like this. This is the dielectric 1. This is the dielectric 2. Oh, sorry, here is not. So here in the distance dy2, this is the distance dy2. In the distance dy2, you have filled dielectric of constant k1, and in another dy2, you have filled dielectric of constant k2. And this is one dielectric, this is another dielectric. So see here now, due to the induction, this is positively charged plate. Here a negative charge will be induced. And here a positive charge will be induced at the interface. So Harsh, this will become a capacitor of capacitance C1. This will become capacitance of capacitor C2. Now please tell me what kind of combination is this?
Parallel.
No, parallel, not parallel. See here.
No, wait. C1 and C2. Oh, it's series.
Yeah, this is a series combination. See how this is a series combination. This is negative, this is positive, and this is negative. So this is positive,
and that's negative.
This is negative. And
yes, sir.
We have oppositely charged plates. So if this plate is positive, this plate is negative. This plate will be negative. If this is negative, this plate will be positive. Means what we are doing in the series combination, we are connecting negative plate with positive plate. So see here. Here this is the negative plate. This becomes the negative plate of the capacitor, and this negative plate is connected with the positive plate of the capacitor. This means that this is the series combination. Okay, got or not?
Yes, sir.
So if you want to find the capacitance C1, and capacitance will equal to K epsilon naught into area divided by distance.
Yes, sir.
Between plates. And this time you can see that the area is not changing. The area of the plate is not changing. Area is same. Here again the area is same of this plate. Area is not changing, but the distance between the plate is changing. So if you want to find C1, then you will write K1 epsilon naught, area is not changing, and distance is d by 2. See here, the distance is d by 2. So this will become 2K1 epsilon naught A divided by d. This is C1, and similarly you can calculate C2. This will become 2K2 epsilon naught A divided by d. And this is the series combination. So in the series combination, the equivalent capacitance will be find out by 1 upon C equivalent in series equal to 1 upon C1 plus 1 upon C2. So 1 upon C1, when you will do 1 upon this will become D upon 2K1 epsilon naught A, and accordingly this one 2K2 epsilon naught A. Now here, what is the common here? Here is D is common, 2 epsilon naught A. D upon 2 epsilon naught A is common, and this will become 1 upon K1 plus 1 upon K2. And when you will finally, you will find 1 upon C equivalent into S. This will become D upon 2 epsilon naught A, and this will become K1 plus K2 divided by K1 K2. After that, this will become 2 epsilon naught A divided by D. Reverse, when you will do the reverse of this. K1 K2 divided by K1 plus K2. So this is the final formula. Okay. Note this down.
Yes, sir.
Or here you can write one line also. Distance divide, when distance, here distance is divided,
Yes, sir.
means series.
Area
Series
divides parallel.
Yeah. You have written this?
No, sir, I have to write it.
Okay. Okay. Write it. And make the diagram properly.
Yes, sir.
Not, I am not saying to use the colors, but you can.
Second scroll down.
So this was the last topic, and we will have one numerical after that. This chapter finished. Earlier we have a single parallel plate capacitor, and what we are doing, we are filling the dielectric with respect to area and with respect to distance. So
Yes, sir.
ultimately two capacitors of different capacities are produced.
Yes, sir.
And the first combination, first we have seen the parallel combination when the positive plate is connected with positive plate, and after that we have seen the series combination in that a positive plate is connected with negative plate. I mean, when you connect the opposite plates of one and another capacitor, then the combination is series. When
Yes,
you
sir.
will connect with the same plates of the one another capacitor, then this
Combination is parallel.
combination is parallel.
Second scroll down.
Here from here, na?
Yes, sir. Sir, just want to have to write that formula, sir, in yellow box. Yes.
Now it's okay.
Yes, sir. Second scroll down. Done, sir.
So this is the question here, and here you can see here the distance is divided. A capacitor is filled with two dielectric of same dimensions, but dielectric constant of 2 and 3. K1 is 2 and K2 is 3. And find the ratio of capacities in the two arrangements shown in. So similar, this is the similar case. Here you can see that here distance is divided, means this is series combination.
Yes, sir.
And here the area is divided, means
parallel.
parallel, and we have formulas.
Yes, sir.
We have formulas.
For parallel epsilon 0 A 2 D by
C
K1
equivalent
K2.
for series,
Yes, sir,
is equal to this formula. 2 epsilon naught A divided by D, K1
Yeah.
K2.
K1 plus K1 K2 plus K1 plus K2.
Yeah, 2 epsilon naught A divided by D. This will become
K1 into K2 divided by K1 plus K2.
K1 plus K2. And they are saying the value of K1 is 2 and K2 is 3.
3. So it will be 2 into epsilon 0 A by D
So 2 into
into
3.
2 into 3 plus 2 plus 3.
This will become 2 epsilon naught A divided by D, and this will become 6 by 5. So equivalent capacitance in series is this. Equivalent capacitance in series is divided by D, 6 by 5. This is equation 1. And in this is for this parallel combination,
Yes, sir.
we have this formula.
Yes, sir.
Epsilon naught A divided by 2D,
2D by
K1 by K2.
Yes, sir.
So the formula is epsilon naught A divided by 2D, K1 plus K2. This is right now. Epsilon naught A divided by 2D. Epsilon naught A divided by 2D, K1 plus K2. Epsilon naught A divided by 2D, K1 plus K2. So epsilon naught A divided by 2D, K1 is 2, K2 is 3. So this will become epsilon naught A divided by 2D multiplied by 5. So they want to find the ratios. They are saying
so
find
will
the ratio of capacities in the two
Yes, sir.
arrangement. Means C
No,
series,
divide
C
them, sir.
parallel. Yeah, this is equation 2. I am just right.
So it will be C series by C parallel.
Yeah. Into this is 2D into 5. Equation 2, divide the equation 1 with 2. You will get CE series, CE equivalent capacitance is parallel. For the series, we have 2 epsilon naught A divided by D into 6 by 5. And for the parallel, we have epsilon naught A divided by 2D into 5. So now we have to perform the calculation here. So this will become 2 epsilon naught A into 6 divided by 5D.
Yes, sir.
This will become 5 epsilon naught A divided by 2D. Now what you will do, for these kinds of calculation, write this first. 2 epsilon naught A into 6 divided by 5D, and reverse of this. In the multiplication, write the reverse of this.
Yes,
2D
sir.
divided by 5
5
epsilon naught.
epsilon A.
Now the war begins. So here epsilon naught gone,
Yes, sir.
A gone,
Yes,
D
sir.
gone. We have 2 and 6 into 2. 6 to the 12, 12 to the 24. And this here we have 5 into 5. This is
Yes, sir.
25. So this is the answer. This is the answer.
Yes, sir. Done, sir.
Yeah. In series. This is the point. So ratio of capacitance in series and ratio of capacitance in parallel. So this was the last question of the chapter, and we have started this chapter from we have a long journey.
Yes, sir.
And I have given the assignment also to you, but you have not completed that. And these 2 points I have at that time I told you that we will do in the next class, but that next class I have also. So we have started from here. Capacitor is started from. So basically, the capacitor chapter capacitance is started from here.
Yes,
From
sir.
here you can revise.
Yes, sir.
You can revise the chapter, and I will give the question from here, and I will give not very complex question. So we have
Easy
started
questions.
what is capacitance, and after
Yes, sir.
that capacitance of conducting sphere.
Yes, sir. 4 pi
4 pi
epsilon
R.
R.
After that we have calculated the capacitance of earth.
Earth.
This is very small, and at that time the capacitance of earth is very small in microfarad. That is why we have produced a device named as capacitor. And capacitor
Yes.
is a device which is used to
To
store
large amount of charge.
large amount of charge, and this device is basically a 2 conductors separated by a small distance.
Yes, sir.
And separated by some medium also. And symbol of capacitor is this.
Yes, sir.
After that we have completed the numerical and all that, and only we have studied this parallel plate capacitor.
Yes,
not
sir.
this. So after
Yes, sir.
that we have studied the what is parallel plate capacitor, and we have calculated the capacitance for parallel plate capacitor for different cases, when dielectric is filled, when conducting slab is filled.
Yes, sir.
So this is very, I don't think this is complex. And after that we have after the capacitance we have the energy stored in the capacitor.
Yeah, half CV square.
Yeah. After that we have energy stored in the capacitor. But I have written only formula, because
Yes,
formula
sir.
is only the part of your syllabus. U is equal to Q square by 2C, and another formula is half CV square, another is half QV.
Half QV.
And after that we have studied the energy density
Amount
the
of
parallel
energy stored
plate
in unit
capacitor.
volume of parallel.
Yeah. Energy density is energy stored per unit volume.
Of parallel
And
plate capacitor.
the formula for energy density is
Half epsilon 0 E square.
And electric field is given by sigma by epsilon.
Epsilon naught.
Sigma is the surface charge density. And after that we have
Yes,
done
sir.
the numericals, and after that we have done the numerical whether we will remove the battery or we will, if you remove the battery then the charge will remain same, If the battery
Yes, sir.
remains connected, then the potential will remain.
Potential remains.
These kinds of questions we have solved. And after that, we have series and parallel combination. In series combination, charge is same. In parallel
Yes, sir.
combination, the potential difference
Potential
is
is
same. This
same.
is the series combination. And here charge across each capacitor is same. And the formula for equivalent capacitance is this: C1,
Yes, sir.
C2, C3.
For series combination.
C3. C3, C4. This is for series combination of capacitor, and we have
Yes, sir.
calculated the terms, energy, and all that. And I have told you that for the two capacitor, you can learn the equivalent capacitance as C1, C2 divided by
Yes,
C1
by
plus
C1 plus
C2
C2.
when the capacitors are connected in series. And we have done the
Series.
question also, and so that we have calculated many terms. And this is the parallel combination. In parallel combination, see here, the potential difference across any of the
Capacitor remains
capacitor is same, but
same.
from this point the
Charge is
charge is
different.
divided because there is
Yes,
a
sir.
branching.
Branching.
And this charge can be write, Q can be write as Q1, Q2, and Q3.
Yes, sir.
Here you can write Q2 also. Q2. Okay, and now we have so that we have the series combination. After that we have parallel combination here. This is, and in the parallel combination, the resultant, or you can say the equivalent capacitance, is come out to be the sum of the capacitance.
Yes,
We
sir.
have calculated the charge, potential, energy, and we have done the numerical. And today we have solved this very good questions.
Yes, sir.
And this this question is, I think, a good question. You can mark it as star. And after that, we have done this when the capacitors are inserted. When in a capacitor, dielectric are inserted along the with respect to area and with respect to distance. And this formula we get for the series,
Yes,
and
sir.
for parallel we got this formula. And after that, we have done this numerical and this. So, Harsh, should I start this chapter current electricity in the next class or in this class?
Sir, you can start in the next class. There, 10 minutes are only left.
Yeah, I know that. But one thing, you should revise the this means this chapter. This is very easy chapter, and
Yes, sir. It's easy.
I hope you will get 100% marks from this chapter if you will study my notes. And okay, that
Yes,
is
sir.
fine. And please revise. And in the next class, we will
Test
have
yourself.
will have a test of 15 to 20 minutes, and I will not give you the complex question.
Yes, sir.